Okay, welcome to the homework walkthrough for pages 75, 85, and 93 due May 28th. We're going to begin on page 75. Again, we're in volume 1 of your Math Common Core textbook, page 75. We're asked to find some square roots. Now, as we look through this, we need to go back and remember what a square root is by looking at things that we call perfect squares, and we had some review on this. We have squares, and these are the perfect squares. So geometrically, this would be a little tiny square. That would be like a 1 by 1, and then we get a little larger. Oops, a little bigger, 2 by 2. Then a little larger, a square. These are all squares. 3 times 3, 4 times 4. And they keep getting progressively larger in real life. And we get areas. The area is 25 because area is side times side or side squared. So we get 16, 9, 4, and 1. And we need to memorize these. From 1 to 15, let's say, the perfect squares. Okay, we call them perfect squares because it's the integers that we're looking at. And then we also have something called the cubes. So we have a similar situation where we have the same dimensions, but they are perfect cubes. So we have 1 by 1, but also going into the third dimension 1 by 1 by 1. So we have 1 cubed. And we do the same thing for 2. 2 by 2 by 2. 2 cubed is equal to 8 is equal to 1. We'll go to 3, a little bigger, sorry. 3 by 3 by 3, or 3 cubed, is equal to 27. So we call that volume, and the volume of a cube is equal to side times side times side, which is equal to side cubed. So that's what we have for volume. So we're looking at 16. We drag over here. 4 squared is 16. Okay, we know that this is the area. All right, the area is 16. So we're looking for a side because the area is 16. We take the square root. We know the area is s squared. We're taking the square root. So we're taking the square root of the area. And the square root is 16 because that's 4 squared. And we take the square root of a squared number, we get 4. So 4. So we're going to do that. We're going to use this table that you were given. That table can be found in your Google Classroom. Negative 484. We get some larger numbers. The negative on the outside is okay. So negative on the outside is okay. But when it's on the inside, it's not okay. And we spent a little time breaking that up into negative 1 times the square root of 36. So we could deal with the negative 1. We say square root of negative 1. We called it I. Oops, a little bit off, sorry. So we're just going to call this thing the letter I for now. That's good enough for 8th grade. And here the square root of 36 is 6, but we don't write the I first. We're going to write 6i. If you plug in this into your calculator, you're going to get undefined. And that's fine. Let's take a look. First, we need to do this one. So we're going to do negative first. Then square root of 484. And we get negative 22. You'll notice when you put in the square root negative. Remember, this is the negative button, not the subtraction button. Negative 36. It's going to come out undefined. Domain error. So the way we get around that, again, we pull that square root of negative 1 out, call it I. And so this is your final answer. So we have other problems like this one. Well, here, notice that all numbers should come out of the square root in both directions, positive and negative. Take this is the square root of the entire thing, so you each is getting the square root. Square root of 9 is 3. Square root of 49 is 7. Then you get numbers like this, and you can just use your calculator. Negative square root of 2.56 is negative 1.6. Note that you could apply this idea that the negative square root of 256 is negative 16. So logically, you could have looked at this number being 2 decimal places off. When you take the square root, you got to move it 1 decimal place, because negative 1.6 times negative 1.6 is is 2.56. You would apply the same thing here. Square root of 25 is 5, so this would be, but you have this negative sign, right? So we'll go, it's 0.5 for this part. We call it I. And we know how to do these. You take the square root of both sides when you have this something squared, so v equals 9. You do for the numerator and the denominator. This, just use your calculator to find c. Pop that number into your calculator. If you don't have a calculator at home, you can go to calculator.com. They have calculators there. Make sure you use a scientific calculator. All right, then we get cube roots. So again, you'd probably want to go back to your little chart here to find 1,728. If I look at my chart, 1,728, 12 cubed. So the cube root of this number is 12. You could apply the rest of that. Okay. Let's go to page 85. Estimating. Now we get into some more fun stuff. Let's do a little estimating. I need a blank sheet of paper here, because when I'm estimating, what I'm doing is I'm looking on a number line that this number is between two numbers. So I'm looking at the perfect squares. Here's the square root of 16 and the square root of 25. This is 5 and this is 4. So where does square root of 23 come in? It's about right here. Square root of 23, really close to 5. So a good estimate would be 5.9 or 5.8. Those would both be reasonable answers. I'd probably lean closer to 5.9. It's going to be a rounding thing. So you can get the exact answer using your calculator. Let's look at this one. 197. So if I go out here, 13 squared is 169, 14 squared is 196, and 15 squared is 225. So we're really close to 14 here. If 14 squared is 196, then this has to be slightly bigger than 14. It would definitely be 14.1. So do that for 3 and 4. You know, use what you know about perfect squares. If you need to build a number line, you can. Square root of 16 is here. Square root of 9. So you know it's closer. This number is really close to right there. Close to 4. You can make Here we do the same thing. Square root of 81 is 9. The next number is 100, so that's 10. So it's somewhere between, right about there. So 9 point what? Oops, again I did, sorry about that. Let me zoom out just a touch so that won't happen. Cube roots. Now you have to do the number line again. You do the number line knowing that the cube root of 8 is 2. And the cube root of 27 is 3. How do I know that? Well, I know the perfect cubes. 3 cubed is 27. 2 cubed is 8. So between 2 and 3, oops, there's a 3. 27. So this radical 22, cube root of 22 is going to be here. A good guess then would be 2.8 maybe, or 2.7. 2.7 or 2.8. Probably I would lean towards 2.8. Now, before we estimate on this one, let's review what you need to use on a calculator in the classroom. You need to hit these buttons. To get to the cube root, you push 3 first. This is this particular calculator. You push the second button. Then the caret button. And then 34, and then enter. So let me try it. Here we have the 3. Second. Oops, second. And then the caret button is here by the 7. And now I have a cube root. And then I type in 34. And that's 3.2 if you go to the nearest tenth. That was not estimated. But instead that was the exact number. Exact answer would be 3.2396. And you want to keep estimating. This is almost 10 cubed is 1,000, so it's got to be about 9.9. 250, go back to here. It's maybe 6.3. And finally, page 93. I'm just going to go over the main bulk of this, not the word problems in this review. Name all sets of numbers to which the real numbers belong. Okay, well, we need to flip back in our book just a couple pages here. And we look at the real number system. Okay, well, here's our real numbers. Remember, real numbers can be fractions. And that's for rational numbers. And then irrational numbers cannot be fractions. So they can't be written as A over B, but this one can be written as A over B. And we went over, that means fractions, mixed numbers, terminating decimals, repeating decimals, and percentages that terminate. So we're looking for those. All right, 2/3. I'll just put R for rational. Oh, everything it belongs to rational. This is negative, and this radical 20 can't be written. It's an irrational number. Terminating, which is it, rational or irrational? It's terminating. 7.2 repeating, that's rational. We went over how you solve that. You do 7.222 equals x. It repeats at every tenth. Every time the decimal moves, it would repeat. So we could multiply by 10. We'd get 72.222 equals 10x. Subtract x. Subtract 7.222. We get 9x equals, all these 2's cancel. We get 65. So x would equal 65 over 9. This is rational. It equals 3. And then you want to do some comparisons. You'd have to use your calculator. Square root of 10 is 3.16. 3.16 is less than 3.2. Now, if you rounded it to the nearest tenth, you'd get 3.2 equals 3.2. They're both okay answers as long as you explain your reasoning. It's a little difficult to go to a more of a precise number than what is given here. So typically, this would be probably the more proper answer scientifically. You can only go to the most accurate as your least accurate measurement. So you do need to round it to this because this was to the 10th. So you better round this one to the 10th. Okay, 5 and 1/6 compared. So we didn't know what 1 divided by 6 is. It's 0.16 repeating. Oh, okay. So there we go. This is equal. Let's do radical 5.2, 2.8 compared to 2.21 repeating. We're going to have less than. And finally, the most important, this is probably is ordering numbers. We need to make sure that's negative 4.15. We take 17. We get 4.12, negative 4.12, negative 4.1, 111, and negative 4.08. These are really tightly bound together. The most negative is here. And then we have one here. To the left of that dash right there, 4.08. So do the same thing for 9. Simplify them first in the decimal form. Then draw some arrows, and that's it. Make sure you turn in your homework if you're in Mr. Garrigus' class. This is the last homework, and it's due May 28th. And attach your work. All right, good luck.